Quantum computing and its implications for data science. Quantum computing is a new field. It uses quantum mechanics to process information. Unlike classical computers, which use bits, zeros and ones, quantum computers use quantum bits, or qubits. A qubit can exist in multiple states simultaneously, thanks to a quantum property called superposition. Also, qubits can become entangled. The role of data science in the modern world. Data science is the discipline of finding insights in data. This data can be structured or unstructured. It involves a blend of statistical analysis, machine learning, data visualization, and programming. Enhanced processing power. A key implication of quantum computing for data science is its ability to process and analyze massive data sets. With traditional systems, analyzing complex data often involves time-consuming computations. Advancements in machine learning. Machine learning, ML, a cornerstone of data science, stands to benefit immensely from quantum computing. Quantum algorithms, like the CAOVA and QSVM, could improve ML models. They may be faster and more accurate. Improved optimization solutions. Optimization problems are common in data science. They range from supply chain logistics to portfolio management. Quantum computing excels at solving complex optimization problems. Efficient data encoding and processing. Quantum computers can encode data into high-dimensional quantum states. This enables more efficient data processing. Techniques like quantum principal component analysis can shrink large data sets. Cryptography and data security. Data security is vital in data science. Quantum computing offers both opportunities and challenges in this area. Quantum computers could break classical encryption. They can factor large numbers, which many cryptographic methods rely on. Conclusion. In conclusion, quantum computing is a major shift in computing. It has huge implications for data science. It can process vast data, optimize complex systems, and enhance machine learning models.